This is our Chapter 9 review. Some of this we did yesterday, but I'll run through those problems for anybody who missed them yesterday. These are supposed to be marked as right triangles in all three cases. We know two legs, and we are supposed to find the missing side length. Not two legs, we know two sides, and we're supposed to find the missing side in a right triangle. That's the Pythagorean Theorem. Now you have to remember, C is always the hypotenuse. So find that guy first if you can. There's our hypotenuse right there. So that's got to be the C. So now we just have to substitute in. I'm going to let A squared be the side or A be the side I don't know. It doesn't matter. And 20 squared. See, 10 squared is 10 times 10. 20 squared is 20 times 20, 400. We'll subtract the 100 from both sides. Excuse me. A squared equals 300. And then we square root both sides to get the A unsquared. Now you get the square root of 300. This is something we did early on in this chapter where we talked about take that 300 and start to factor it. It's 3 times 100, and that's 3 times 10 times 10, and I'm going to stop there because, see, I've got two of a kind. Remember, this is a square root, so it's saying, what do you have two of a kind of? I got 10, two of those, and then that 3 has to stay inside the radical. So that is how long side A there is, the missing side, 10 root 3. And that's a number, you always have to remember that, 10 root 3. I just took the square root of 3 on my calculator, now times 10. So that side is about 17.3 feet or inches or yards, whatever they're measuring in. Let's look at number 2. Again, a right triangle. I know two legs, so I just want to find that third side. Now that third side in this case is the hypotenuse. So we'll go A squared plus B squared, so we'll just call one of the legs A and one of the legs B equals our hypotenuse squared, or C squared. I'm just going to leave it as H, so that's 25. 13 squared is 169. If you don't know that, go to your calculator, type 13, and just hit that X squared button. Equals H squared. Now I got to add 25 and the 169. I've already got the 169 on my calculator, so I'll just add the 125 to it. And I've rotated the equation because I'm ready now to square root both sides and have my answer. So H is the square root of 194. We do want to check to see if that breaks down, so we take the 194 off to the side and let's start to factor it. That's 2 times 97. And 97, if you start to try to think of factors of it, clearly it's not 2 or 3. And I actually checked this yesterday because I couldn't think of any. 97 is a prime number, so it can't be factored any further. We don't have a pair of anything in here, and therefore we just leave it as the square root of 194. If you wanted a decimal, that means it's about 13.9 or 14 inches or feet or whatever long. Number 3, let's see here, A squared, one of our legs, plus, oops, don't know a leg, so I'll call him B. Notice I have squareds on each one of those. Let's find out what 17 squared is. 289. Let's find out what 19 squared is. 361. Now I'm going to have to subtract that 289 from both sides. The nice thing is, if you have your calculator handy, all I have to do is type in minus 289. And so much for me, showing you how easy it was. 361 minus 289. 72, so b squared equals 72. Now we got to square root both sides and we will almost be done. So b equals square root 72. We take the 72 off to the side and we start to factor it. And see, I notice right away it's 2 times 36. I can square root 36. Square root of 36 is 6, and that 2 has to stay inside. Problem number 4. To get from point A to point B, you must avoid walking through a pond. So let's see if we can draw this here. Well, we're going to put out a blank piece of paper to draw it on. Let's go ahead now. Sorry about that pause. And let's draw a picture. So we've got ourselves a pond. And let's see here. You're going from point A to point B. You don't want to walk through the pond. To avoid it, you must walk 30 meters south and 41 meters east to the nearest meter. How many meters would you save if you walked through the pond? So let's first define north, south, east, west. So on our compass, north is up, south and east is to the right, and west. From point A to point B, and they're going to start by walking south. So point A must be up here. Then they walk south. I gotta be straight south here, at least close to it. They walk straight south for 34 meters. Then they walk 41 east. So over here, it's 41 east. And the question is, how much would they save if instead of going around the pond, they somehow could all of a sudden walk on water and they just cut across like that? Hopefully, if you do the drawing like this, you can see these are the legs of a triangle because north and east, these are all at right angles in a compass. So east or north and east are at a right angle. And we can use the Pythagorean theorem for it now. That'll tell us how long that hypotenuse is. So we will go, so if we just move this, a squared plus b squared, so 34 squared plus 41 squared equals the hypotenuse, which is AB squared. So getting out the calculator, 34 squared plus 41 squared equals 2,837. And we're just going to square root that. It turns out when you square root, so boom and boom, AB is equal to 53.3 meters. Now we got to make sure we answer the question, how much less would they walk, or how many meters would be saved? There we go. Well, let's figure out how much they walked the first way they did it. There they walked 34 and 41, so 34 plus 41. When they walked around it, they went 75 meters. When they took the shortcut, they went 53.3. So the difference would be how much they saved. So minus 75, and we'll change the sign on it. So they saved about 21.7 meters of walking. Not bad. And finally, number 5, we got a suitcase here. So let's get a new piece of paper. Suitcase, so draw a little suitcase. Here's mine. Get a handle on mine. See, the suitcase isn't very rectangular, but it should be. There we go. It's 24 inches long. 24 inches. Diagonal is 30, so diagonal is 30. And yeah, they are rectangles. suitcases are. So it is a right angle right here. Question is how much material is needed to cover one side? So we are trying to basically find the area of the suitcase. And so to do this, what we can find out is the width of it. And once we know the width, remember area of a rectangle is length times width. And so we've already got the length. We just need to figure out what this W is, and we'll use the Pythagorean theorem for it. So one of our legs is 24. The other one we don't know, but we do know the diagonal or the hypotenuse. So 24 squared, oops, there we go, 576 plus W squared equals 30 squared, which is 30 times 3,900. So when I subtract 576 from both sides, I get 324. And then I'll just square root that 324. There we go. It is 18, in this case, inches. So now to find the area, we just do area equals length times width up here. So our length is 24, our width is 30, so 30 times, no, our width is 18. There we go. So 24 times 18, so times 24. Looks like 432 square inches. And that is problems 1